We're going to start 1-4. Make sure that you are taking notes. This is a very important section as we'll follow it throughout the rest of the year and we'll add on to that. So the first thing we need to do is define a few words. The first of these is array. Array is just a part of a line. Well, that's really vague, right? So we need to be a little more specific than that. So it's a part of a line. It has one definite endpoint. And extends forever or indefinitely in the other direction. Or in one direction. Okay, so for instance, if I make an endpoint here, let's call it A, and then I extend that out in one direction, it doesn't matter what direction, forever, that is array. So to name array, we actually name it the same way we would a line, except for the top is different. So let's add another point. We need two of them. We're going to add a B down here, and we would call that ray AB. Okay, and so you can see the mark on it has an endpoint and then just one arrow instead of two that we use for a line. This is really, really important notation, and it's notation that is messed up a lot. So the endpoint needs to go first, and then whatever direction it's extending in goes after that. That's very, very important. Alright, the next thing we're going to look at is an angle. And an angle is just formed by two rays that share an endpoint. So for instance, this is an angle, okay? Now when you're naming an angle, there are several different ways that you can do it. You can name it by the vertex, name it with 3 points, or you can name it by a number. Alright, and so we're going to go into naming that a little bit. But first of all, let's look at what it means to be the sides or the vertex of an angle. The sides of an angle are the two rays that it's formed by. Okay, so for instance, in our example, the sides of the angle would be ray AB with the arrow in the direction of B, and then ray AC with the arrow in the direction of C. Okay, and then the vertex of the angle is where the two rays meet. So where those two rays touch, that point, that is your vertex. So here, it's just point A. A is our vertex there. So when we're naming an angle, we can either use the vertex or 3 points. So for instance, to name this angle, we could call this angle A. That's naming it by its vertex. We could also call this angle BAC. We could also call this angle CAB. When you are naming with 3 points, the vertex of that angle, the point of that angle, has to be in the middle. Has to. I could not call this angle ABC. A is not in the middle. The vertex is not in the middle. It will not work. Okay? And then I can also use a number. So angle 1 will also work. Alright, an angle also has an interior and an exterior. We're not going to go into that really, other than naming points that are in the interior of this angle would be, for instance, points S and point R. those are inside of the angle, and then some exterior points would be P and O. Alright, Q, M, and N are on the angle. They are not neither inside nor outside. But interior would be actually inside those two rays. Exterior would be outside of those two rays. And then also, this is a protractor down here. I'm actually going to show you how to use those tomorrow. So we're really not going to go into it then. I have a class set that I'll allow you to use. Alright, next we're going to look at the types of angles. So we have to be able to classify angles by types, and when I say a certain angle name, you need to immediately know what I'm talking about. So the first of these is a right angle. A right angle has a measure that is exactly 90 degrees. Okay, and then oftentimes a right angle is denoted by a little square in the corner, just like that. That means that is a right angle. The next type is an acute angle. An acute angle is just an angle whose measure is less than 90 degrees. It cannot be 90 exactly, but 89 is an acute angle. 1 is an acute angle, okay? And then the last one we have is an obtuse angle. An obtuse angle is an angle whose measure is greater than 90 degrees. So it's a big angle, all right? So it's really important that you know those types. We're going to go ahead and look at this bottom picture. We're going to classify these three angles. Okay, so let's look at AEB. And we don't know their exact measures. I really just want you to classify it as right, obtuse, or acute. So you can see that this is definitely less than 90 degrees. Therefore, it is an acute angle. All right. Let's look at the next one, CED. Now, this is kind of hard to figure out what angle it's talking about. Just go through the points. So I'm going to start at C. I'm going to go to E, then down to D. So I know I'm talking about this angle here. Alright, that angle has a mark, and we know that that mark means that it's a 90 degree angle. So this one is a right angle. And then the last one we have is angle DEA. That is this angle here. That is definitely greater than a corner, so that means it's an obtuse angle. Alright, easy enough, right? Okay, moving on. Congruent angles. Congruent angles are just angles that have the same measure. And we have some notation for congruent that we need to go over. It is an equal sign with a squiggly on the top. That means congruent. So, if we are looking at the following pictures, we also have marks. So, angles are congruent when they have the same amount of marks, the same number of marks, or if we know the measure of each and they are equal. That's another way to tell. So let's look at the first angle we have here, ABC. I want to know what angle is congruent to ABC. So you can see that I know it's 65. So I automatically know this angle, that's 65, is congruent to it. You can also see that it has one mark. So this angle also has one mark. That is another way to tell they're congruent. So again, when we're naming this angle, the vertex must go in the middle. The vertex here is E. E's got to be in the middle. And then the two other points can go on either side. So we can call this angle DEF. Those two angles are congruent. Let's look at the next pairing. DEB. DEB is this angle here. You can see it has 2 marks. So the other angle with 2 marks is congruent to it. So we have here, this angle has 2 marks. So we could call this B is the vertex, so it goes in the middle. So that could be angle C. So there are the answers to the try it problems. Number 7 was a little bit difficult. What you had to do there is realize that angle NKM and angle NKL are congruent since KN is a bisector. Once you know they're congruent, you can add together their two measures just like I did here, and equal it to the measure of the entire angle. Once you did that, solve for x and plug it back in to get that angle degree. Okay, we'll talk about this in class first thing tomorrow.